everyone, welcome back to my channel. In today's lesson, we are going to learn homogeneous differential equations. By the end of this lesson, students will be able to identify a homogeneous differential equation, how to use the substitution by y is equal to ux or y is equal to vx, solve homogeneous differential equations step by step, apply correct IB mathematical communication. Now let's look at the definition. A first order differential equation of the form dy by dx is equal to f of y over x is called a homogeneous differential equation. For example, dy by dx is equal to x plus y over x is a homogeneous differential equation. Which, or if we simplify it further, we can write it in the form of, so the given equation is a homogeneous differential equation. Now there are a few steps involved. We'll solve this example at the end after we write all the steps first. Step number 1. If we are having a first order differential equation of the form dy by dx is equal to f of y over x. So first step is identify. Identify right hand side. That is of the form f of y over x. Now here we have identified right hand side is of f of y over x. Step number 2. Put y over x, substitute is equal to, let's say, u or v, whatever is convenient, or we can say y over x, simplify, x times u, so that is the product of 2 now. Step number 3, identify, step number 3, differentiate by product rule, dy by dx, derivative of x is 1, u plus x into du by dx, or we can just write u plus x into du by dx. Step number 3, then step number 4, substitute this expression in the given differential equation over here in this. Dy by dx is u plus x into du by dx, that is equal to f of u. Step number 4. Step number 5, separate the variables. How we solve? By separating the variables, u on one side, so x into du by dx is equal to f of u minus u. Then step number 6, after separating the variables, so we can integrate, or first we can simplify further after separating the variables, is equal to 1 over x to dx. Step number 6, integrate, so integrate left hand side respect to u and right hand side respect to x. Then step number 7, resubstitute, write the answer in terms of y as a subject. So resubstitute y is equal to u over x, so u over x in the answer, and write the answer in the form of y as a subject. In the form of y as a subject. Y as a subject. So let's take one example. Dx is equal to x plus y over x. Part A, show that it's a homogeneous differential equation. Use y is equal to ux to find the general solution. That's part B. And part C, hence find y at, so command term is hence, find y at e and e square. Okay, so let's solve. First we are given, we have to identify right hand side, that is x plus y over x. We just write as it is and then simplify and make it in the form of y over x, 1 plus y over x, that is of the form f of y over x, a part. Therefore let's say homogeneous differential equation. I took a simple example to just build the concept. We will practice difficult questions also. B part. Now substitute y is equal to, B part is substitute y is equal to ux or vx, whatever, ux, okay. So differentiate, apply the product rule. dy by dx is equal to u into 1 plus x into du by dx. Then substitute this in over here. So therefore the equation becomes u plus x into du by dx is equal to 1 plus u, because y over x is u, so therefore we can cancel u and u from both sides, and then cancelling u and u from both sides, that implies x into du by dx is equal to 1. We have to keep in mind the proper notations steps. In each step, du is equal to 1 over x into dx after separating the variables. Therefore integrate, so integrate du ln x plus c. Do not forget to how to apply the product rule. Do not forget the modulus, and do not forget constant of integration. Now, and do not forget to resubstitute the last step. U, since u is equal to y over x, so therefore y over x is equal to ln magnitude of x plus c. Right, y as a subject, x times ln of magnitude of x plus c. C is a constant and a real number. Now that is the general solution. The general solution in 1. So e square is equal to e times in the bracket magnitude of e plus c. We know magnitude of e, ln e is 1. So e square, e and e can be cancelled. E is equal to 1 plus c. That implies c is equal to e minus 1. And we plug this value of constant in equation number 1. Therefore, equation number 1 implies y is equal to x into ln magnitude of plus e minus 1. That is the particular solution. Thank you. Let's take another example.
Kindly practice this question by yourself. Feel free to approach in case you have any doubts. Thank you.